What I'm about to tell you will fundamentally change how you see yourself in space. Right now, at this exact moment, you are moving at 600 kilometers per hour. Not relative to the ground, not relative to the sun. You're moving through the universe towards something massive, something mysterious, something that scientists still don't fully understand. And here's what will blow your mind. None of us know where it is. Think of it like this. Imagine you're on a train. The lights are off. You can't see outside the windows, and the train is accelerating. You feel the acceleration. You know you're moving, but you have no idea where the train is going or even where the train station is. That's humanity right now. We're being pulled through space by something we can barely detect. In 1986, scientists noticed something absolutely terrifying in the cosmic structure. Galaxies were moving in the same direction as us, like iron filings pulled toward an invisible magnet. By 1987, astronomers realized Earth wasn't just moving through space randomly. We were part of something much, much bigger. A cosmic flow, a great attractor. And it's still pulling us. Before we explore one of the biggest mysteries in cosmology, I've got to ask, where are you watching this from right now? Comment below what country, what time is it for you? Because you're about to become part of a global conversation about the structure of reality itself. And yeah, hit that subscribe button, because each section gets more incredible than the last. By the end of this, you'll see the universe and your place in it completely differently. Most people go through their entire lives thinking Earth is stationary, or maybe moving around the sun. They have no idea, no concept whatsoever of the cosmic currents carrying them through the void at speeds that would annihilate any spacecraft we've ever built. This video changes that. This video is where you learn the truth about what's pulling us. What if I told you that there's something so massive, so powerful, that it's literally bending the fabric of space itself in our direction? What if I told you that this thing, this attractor, might be the reason your atoms exist in this exact configuration right now? That's not poetry, that's physics. And we're about to dive into it. In the next section, we're laying the foundation. We're going back to basics, but not the way you learned in school. We're going to rebuild your understanding of gravity, motion, and cosmic structure from the ground up. Because to understand the Great Attractor, you first need to understand how the universe moves. Stick around, this is about to get real. Here's something that's been bothering physicists for decades. Our universe is supposed to be isotropic. That's a fancy word meaning the same in all directions. The universe looks the same if you look left or right, up or down, forward or backward. Right? Wrong. This is where Edwin Hubble comes in. In the 1920s, Hubble discovered that galaxies weren't just sitting still in space, they were receding from us. In fact, the further away a galaxy was, the faster it was moving away. This is the foundation of everything we're about to discuss. But Hubble missed something. His instruments weren't sensitive enough to detect what we now call bulk flow, the systematic motion of entire regions of space. In 1977, something extraordinary happened. Astronomers Richard Croft and Henry Arp started analyzing the redshifts of distant galaxies, basically the colors of light coming from them. They noticed something strange. Galaxies weren't just receding uniformly in all directions. There was a direction, a vector, a cosmic wind pushing everything, including us, in a specific compass direction. This wasn't a gentle breeze. This was acceleration. Think of it like this. You're standing in an airport terminal, and you think the air is still. But then you notice that all the dust particles, all the people, everything is slowly drifting toward gate B7. That's not random. That's a current. That's the cosmic bulk flow. And we're dust particles on a very large scale. By the 1980s, scientists had developed something called dipole anisotropy measurements. They could measure the subtle difference in cosmic background radiation. That's radiation left over from the Big Bang in different directions. And when they did this, the evidence became undeniable. The universe wasn't isotropic. It was directional. It was flowing. Here's the data. In one direction of the sky, the cosmic background radiation is slightly hotter. In the opposite direction, it's slightly cooler. This temperature difference, called the dipole, tells us that we're moving at approximately 600 kilometers per second through space. But that's just the velocity we could detect based on radiation patterns. The real question was, what's causing this motion? What invisible force is pulling us? And here's where it gets stranger. This 600 kilometer per second motion, that's on top of Earth's rotation, on top of our orbital motion around the Sun, on top of the Sun's motion around the galaxy, on top of the galaxy's motion through the universe. You're experiencing motion about 5 different ways simultaneously, and most people have no idea. Think of it like concentric circles of motion. A child on a merry-go-round is spinning Earth's rotation. A merry-go-round is moving through a park, orbiting the Sun. The park is on a train, moving with the solar system through the galaxy. The train is on a ship, the galaxy moving through space. And the ship is caught in an ocean current, the bulk flow toward the Great Attractor. You're experiencing all of these simultaneously. Now, some of you are thinking, if we're moving that fast, why don't we feel it? And that's the right question. It's because motion is relative. You don't feel motion. You feel acceleration. Your body experiences acceleration. But motion at constant velocity? Your body adapts to that instantly. The universe is essentially a perfectly smooth, perfectly frictionless space. You could be moving at any speed, and as long as the acceleration is 0, you wouldn't feel a thing. But here's where the mystery deepens. The dipole anisotropy explains one component of our motion. But in the 1980s, scientists discovered something else. There was more motion happening, deeper, stranger motion. Motion that came from something invisible, pulling us from far, far away. Something so massive that it was warping the structure of space itself. By 1987, they had a name for it, the Great Attractor. Here's a question that will haunt you. If you could measure the exact motion of our galaxy through space with absolute precision, and you accounted for our solar system's motion, and you accounted for Earth's motion, and you accounted for everything we can measure, would the numbers add up? Would you have explained all the motion we observe? The answer is no. And in 1983, something incredible happened that changed everything. A team of astronomers discovered what they called the large-scale anisotropy. Their leader was George Smoot, a physicist at UC Berkeley. What Smoot's team found was revolutionary. George Smoot and his colleagues were analyzing data from the COBE satellite, that's the Cosmic Background Explorer. They were measuring the cosmic microwave background, the afterglow of the Big Bang, with unprecedented precision. And they found something that shouldn't exist: patterns, anisotropies, asymmetries in a radiation field that was supposed to be uniform. Smoot would later win the Nobel Prize in Physics in 2006 for this work. But the implications were even deeper than that. The cosmic microwave background isn't just ancient light. It's ancient light from every direction. It's a snapshot of the universe when it was only 380,000 years old. And that snapshot was telling us that we and everything around us were moving through space in a specific direction. But it wasn't just telling us about our galaxy's motion. It was telling us about something bigger. A structure, a flow, a cosmic attractor. In 1986, a different team led by John Koshlinsky at NASA's Goddard Space Flight Center and David Burstein at Arizona State University made an astonishing discovery. They were analyzing the peculiar velocities of galaxies. That's the difference between how fast a galaxy appears to be, moving away from us based on redshift, and how fast it should be moving based on the universe's expansion rate. The difference revealed something extraordinary. Think of it like this. You're on a train, and you notice that other trains around you aren't moving away at the speed you'd expect. They're moving away faster in one direction, slower in another. Some are even moving toward you slightly. That's not random train traffic. That's because there's a force pulling all the trains in one direction. That's what the peculiar velocities revealed a systematic pull. When Koshlinsky and Bernstein analyzed the data, they found something remarkable. Out to a distance of about 200 million light-years, galaxies were moving in a coordinated pattern. They weren't just receding from us uniformly. They were flowing, like water down an invisible slope. And that slope pointed toward a region of space we couldn't see. A region of space about 200 million light-years away, in the direction of the Centaurus supercluster. By 1987, Alan Dressler at the observatories of the Carnegie Institution made a crucial discovery. He confirmed the bulk flow and identified what might be causing it. Dressler's work revealed that the Great Attractor wasn't a single massive object. It was something far more complex, a supercluster of galaxy clusters, a cosmic structure so dense, so massive, that it was literally bending space in its direction, pulling us toward it like a drain pulls water. Here's what will blow your mind. The Great Attractor has enough mass to be pulling an area of space trillions of light-years in volume. Not just our galaxy, not just our local group. Entire superclusters billions of light-years away are being influenced by this structure, and we're in its grasp. We have been for billions of years. We always will be. Think about this. Your atoms came together because of this pull. The solar system formed where it did because of this pull. The Earth exists in its current position because of this cosmic force. Without the Great Attractor, you wouldn't exist in this configuration. That's not metaphorical. That's literal physics. But here's the thing that will really blow your mind. We still haven't found it. We can detect its gravitational influence. We can measure it pulling entire superclusters. But we can't see it. In the next section, we're diving into why. And it's going to challenge everything you think you understand about matter, energy, and what real means. What if I told you that 95% of the universe is invisible? What if I told you that everything you can see, every star, every planet, every galaxy, every atom that makes up your body, is the minority? That's not speculation. That's observational astronomy. And it fundamentally changes what we're looking for when we hunt for the Great Attractor. In 1933, an astronomer named Fritz Zwicky was studying the Coma Cluster, a collection of about 1,000 galaxies held together by gravity. Zwicky did something simple. He measured how fast these galaxies were moving. Then he calculated how much mass would be required to keep them from flying apart. The answer shocked him. Fritz Zwicky discovered that the visible matter, all the stars, all the gas, all the observable stuff, could only account for about 1% of the mass needed to hold the cluster together. The rest was invisible. Zwicky called it dark matter. Most scientists ignored him for 40 years, until Vera Rubin proved him right in the 1970s. Vera Rubin studied galaxy rotation curves and discovered something that shouldn't exist. Galaxies were rotating too fast. According to visible matter, they should have flown apart. But they didn't. This could only mean one thing. There was massive amounts of matter we couldn't see, creating additional gravity, holding everything together. Dark matter was real. Think of it like this. You see a flock of birds moving together in perfect formation. You measure their speed, calculate the centripetal force required to keep them in formation, and realize there's no way the bird's wings generate enough lift. Something else must be holding them together. An invisible wind. That's dark matter. It's the invisible wind holding the universe together. Here's the breakdown of what we know is in the universe. About 5% is ordinary matter stars. Planets, atoms, you, me, everything we can see or touch. About 27% is dark matter, something we can only detect through gravity. And about 68% is dark energy, something even weirder that we'll get to soon. But for now, understand this. When we look for the Great Attractor, we're not just looking for visible galaxies. We're looking for a concentration of dark matter massive enough to bend entire regions of spacetime. And here's what's truly mind-bending. We don't know what dark matter is. We have theories. WIMPs, weakly interacting massive particles. Axions, hypothetical elementary particles. primordial black holes, sterile neutrinos. But we haven't directly detected any of these. We infer dark matter's existence only through gravity. It's like knowing someone is in your house because you see their footprints, but you never see them. They stay invisible. They're always there. The Great Attractor, most likely, is primarily composed of dark matter. It's not billions of stars clustered together. It's a concentration of invisible matter, so dense that its gravity reaches across hundreds of millions of light years, pulling everything in the universe toward it. Imagine an invisible drain in space. We're spiraling toward it. Galaxies billions of light years away are spiraling toward it. And we don't even know what the drain is made of. Let that sink in for a moment. Everything you can see in the universe is approximately 5% of what's actually there. The rest is invisible. And the most dominant forces in the universe, dark matter and dark energy, are completely mysterious. We navigate by their gravity. We can measure their effects. But we can't see them. We can't touch them. We barely understand them. You are made of the 5%. Your consciousness, your body, your entire existence is constructed from the universe's minority component. You are rare. You are precious. You are the exception. But you're being pulled through the void by the 95% you can't see. That's your relationship with the cosmos. But we're not done with the mysteries. In fact, things are about to get exponentially stranger. Because the Great Attractor isn't just pulling us through space. It's embedded in a structure that's only been discovered in the last few decades. A structure so vast, so complex, that it makes our understanding of the universe seem almost childlike. In the next section, we're exploring the cosmic web, the hidden architecture of everything. If you've ever looked at a spider web at dawn, covered in dew, you've seen something that looks remarkably similar to the structure of the universe. Strands, nodes, vast empty spaces. The universe isn't randomly distributed. It has architecture. And we only discovered this architecture in the 1980s. Imagine this. For centuries, we thought galaxies were randomly scattered through space, like salt randomly sprinkled on a table. Then, in the 1980s, astronomers started mapping galaxies in 3 dimensions. They measured their distances using redshift, their positions using telescopes, and they created 3-dimensional maps. The results were staggering. Galaxies weren't random. They formed walls, filaments, sheets of galaxies separated by enormous voids, cosmic deserts where almost nothing existed. It was as if the universe had organized itself into a structure as intricate as the neurons in your brain. Clusters of galaxies connected by filaments of matter with vast empty spaces between. This is the cosmic web. Think of it like a city. In a city, there are neighborhoods, clusters of galaxies. These neighborhoods connect via highways, filaments. And between the highways, there's empty space, uninhabited zones. The universe is organized exactly like a city, except the neighborhoods are billions of light years across, and the distances between them are even more incomprehensibly vast. The cosmic web became clear when astronomers like Margaret Geller and John Huckra at the Harvard-Smithsonian Center for Astrophysics created detailed maps of the galaxy distribution. What they found changed cosmology forever. The universe wasn't uniform. It was structured. It had topography. It had landscapes of matter and voids. And embedded in this structure was the Great Attractor. The Great Attractor sits at the intersection of multiple filaments, like a node where several highways meet. The Centaurus supercluster, the Hydra Centaurus supercluster, and other massive structures of matter converge in this region. A combined gravitational pull of all this concentrated matter creates a well in spacetime, and everything falls toward this well. We're falling toward it. Everything in our supercluster is falling toward it. But here's something even stranger. The Great Attractor is pulling us, but we're not alone in the universe. There are other structures pulling in other directions. The Great Void, an enormous region of space, nearly 1 billion light years across, where almost no galaxies exist. Our supercluster sits on the edge of this void. The void's existence or non-existence might explain part of our cosmic motion. To give you perspective, the distance from Earth to the Sun is 150 million kilometers. The distance from Earth to the nearest star is 40 trillion kilometers. The distance to the Great Attractor is 200 million light-years. That's 1.9 quadrillion kilometers. And that's not the edge of the universe. That's just the beginning. These distances are so incomprehensibly vast that they fundamentally challenge your ability to conceptualize space. Here's what's important to understand. The Great Attractor is part of a larger cosmic structure. It's not an isolated feature. It's part of a supercluster, which is part of the cosmic web, which is part of the observable universe, which might be part of the entire universe, which might be infinite, or it might have a structure we can't see from inside it. You exist in this structure. Your atoms were forged in stars that formed in galaxies, that exist in clusters that sit on filaments of the cosmic web. Your existence is contingent on this three-dimensional architecture. Change the structure even slightly, and you wouldn't be here. That's not poetic. That's cosmological fact. But we're about to discover something even more profound, because the Great Attractor isn't just pulling us through space. It's embedded in a cosmic flow that extends across the entire observable universe. And there's something pulling the Great Attractor itself, something bigger, something we're only beginning to understand. In the next section, we're going to explore the Shappley supercluster and how it changes everything. What if I told you that the Great Attractor itself is being pulled? What if I told you that an even more massive concentration of matter lies beyond it, pulling both the attractor and us in its direction? Most people who hear about the Great Attractor think it's the ultimate destination. They're wrong. It's a waypoint. In the 1990s, astronomers discovered something that made the Great Attractor seem almost quaint. They found the Shappley supercluster, a concentration of matter so massive, so extensive, that it dwarfs everything we've discussed so far. The Shappley supercluster is approximately 500 million light-years away. Its mass is about 10,000 times the mass of our Milky Way galaxy. The Shappley supercluster was discovered and named after Harlow Shapley, an astronomer who revolutionized our understanding of the structure of the galaxy in the early 1900s. Though Shappley himself didn't discover the supercluster named after him, the astronomical community named it in his honor because it represents the kind of large-scale structure Shapley's work pioneered the methodology to understand. Here's what will blow your mind. The Shappley supercluster is so massive that it's likely the attractor itself, or at least the primary component of what we've been calling the Great Attractor. The attractor might just be the nearest, most gravitationally dominant feature of the Shappley supercluster. We've been looking for a mystery force, and the mystery force turns out to be an enormous accumulation of matter we've known about for decades. Think of it like this. You're in a fog, and you notice a gentle wind pushing you. You assume there must be a small fan nearby pushing you. But as the fog clears, you realize the wind isn't coming from a small fan. It's coming from a hurricane hundreds of miles away. The Shappley supercluster is the hurricane. The Great Attractor is just the wind we can feel from up close. But here's where it gets truly mind-bending. The Shappley supercluster isn't at rest either. It's not the ultimate center of everything. It's part of an even larger structure, the Pisces-Cetus supercluster complex, which is part of the Laniakea supercluster, which is part of the observable universe, which might be part of something even larger that we can't see because the light from it hasn't reached us yet. Let me break down the hierarchy. Earth orbits the Sun. The Sun orbits the Milky Way. The Milky Way is in the local group of galaxies. The local group is in the Virgo supercluster. The Virgo supercluster is part of the Laniakea supercluster. The Laniakea supercluster is being pulled toward the Great Attractor. The Great Attractor is probably part of the Shappley supercluster. And above that, we don't know. The structure might keep going. Infinite nesting. Infinite complexity. This is one of the strangest concepts in cosmology. The universe appears to have recursive structure, like Russian nesting dolls or fractals. Small structures within medium structures, within large structures, within cosmic structures we can't even perceive. You're experiencing this right now. You're inside structures, within structures, within structures. And you'll never escape that nesting, because the nesting appears to be fundamental to how the universe works. Most people, when they learn this, feel something. It's usually a mixture of awe and insignificance. You realize that you're on a planet that orbits a star in a galaxy, in a cluster, in a supercluster, in a structure. That's part of other structures extending infinitely, or at least beyond the limits of our perception. That awareness, that recognition of your position, is one of the most important realizations you can have. But here's the twist, that insignificance is also profound significance. You exist, you are conscious. You can contemplate the universe. That's extraordinary. You're the universe contemplating itself. You're a way that this cosmic structure has organized itself to become self-aware. You're not insignificant. You're a rare expression of the universe's ability to know itself. But we're still not at the deepest mystery. In fact, we've been approaching this wrong. We've been thinking about the Great Attractor and the Shappley supercluster as if they're fixed destinations. But they're not. They're moving. And what we're about to discover is that nothing in the universe is fixed. Everything is flowing. Everything is moving. And the flows are much deeper, much stranger than anyone expected. Everything we've discussed so far, the Great Attractor, the Shappley supercluster, all the cosmic structures, we've been talking about them as if they're destinations. But here's what's actually happening. They're all moving, and they're moving towards something even bigger, something so vast that its gravity affects entire regions of the universe. Scientists call it the flow or the bulk flow, but what it really represents is motion on a scale almost beyond comprehension. In the late 1990s and early 2000s, astronomers began discovering something revolutionary. The universe isn't organized in concentric shells expanding from the Big Bang. It's organized in flows. Streams of matter moving through space-time like currents in an ocean. And we are in one of these currents. Our entire supercluster is being swept along by a current that extends across billions of light years. Think of it like ocean currents on Earth. Warm water flows from the equator toward the poles. Cold water flows back. These currents interact, create patterns, and move ships in directions sailors might not realize. The universe is exactly like that, except the currents are made of matter and dark matter, and they stretch across mind-bending distances. We're ships in a cosmic ocean, and we're barely aware of which current is carrying us. Here's what will blow your mind. The Milky Way, the Andromeda Galaxy, the Centaurus supercluster, the Shappley supercluster. All of these are moving together in the same direction, in the same cosmic flow. They're all being carried by a current that extends possibly across the entire observable universe. This isn't the expansion of space from the Big Bang. This is something different. This is an acceleration toward a specific region of space. The question astronomers can't answer is, what is causing this flow? What is so massive that it can pull billions of trillions of galaxies in the same direction? Some scientists have proposed something they call the dipole repeller, a vast region of underdensity, an anti-attractor that's pushing everything away from it, which would result in flow toward the attractor. But that's speculation. The truth is, we don't know what's causing the flow. George Smoot, the scientist we mentioned earlier, who discovered anisotropies in the cosmic microwave background, spent decades studying these flows. His work revealed that cosmic flows are fundamental to how the universe is organized. They're not aberrations. They're not mistakes in the data. They're how the universe actually works. Matter flows. Energy flows. Space itself flows. Everything is in motion. Let's stack your motions again, but this time including what we've just learned. Right now, you're rotating with Earth, 1,000 miles per hour. Earth is orbiting the Sun, 67,000 miles per hour. The Sun is orbiting the Milky Way, 500,000 miles per hour. The Milky Way is moving through the local group, 1.3 million miles per hour. The local group is moving toward the Great Attractor, 1.3 million miles per hour. And your entire supercluster is caught in cosmic flows that are carrying you toward something. We don't know what, but the acceleration is real. It's measurable, and it's happening to you right now. This creates an interesting paradox. If everything is moving toward the same attractor, if the universe has a preferred direction, then doesn't that mean the universe isn't homogeneous and isotropic? Doesn't that mean there's something special about this direction? Doesn't that mean the universe might not be the way Einstein's theory suggested? Well, yes. And that's one of the deepest mysteries in cosmology right now. The universe appears to have asymmetries on large scales, preferred directions, structures that are pulling matter toward them with such force that entire superclusters are accelerating. This challenges some of our most fundamental assumptions about how the universe works. And it opens up possibilities, both scientific and philosophical, that we're only beginning to explore. But there's something even stranger we haven't discussed yet. While we're being pulled toward these attractors, something else is happening. Something is accelerating the expansion of the universe. Something is pushing galaxies apart faster and faster. We have a universe being simultaneously pulled and pushed. We have forces acting in opposite directions, and we don't understand either of them. In the next section, we're exploring dark energy and how it transforms everything we've learned. Here's one of the strangest contradictions in physics. The universe is expanding. Galaxies are moving away from each other. But at the same time, gravity is pulling everything together. These are opposite forces. So the expansion should be slowing down, right? Everything should be decelerating as gravity wins the cosmic battle. Except it's not. The expansion is accelerating. And that means something is pushing outward harder than gravity can pull inward. In 1998, two teams of astronomers, one led by Saul Perlmutter and Adam Rees at UC Berkeley and Lawrence Berkeley Lab, and another led by Brian Schmidt, made a discovery so unexpected that it seemed impossible. They were studying distant supernovae, trying to measure how fast the universe's expansion was slowing. The data suggested it wasn't slowing at all. It was speeding up. Saul Perlmutter and Adam Rees shared the Nobel Prize in Physics in 2011 for this discovery. It was considered one of the biggest breakthroughs in cosmology since the cosmic microwave background discovery. Their finding revealed that something invisible, something pervasive throughout the entire universe, was working against gravity. They called it dark energy, and it comprises 68% of the universe's total energy density. Let me state this clearly. 68% of the universe is something we don't understand. It's not matter. It's not radiation. It's something else entirely. It fills every cubic centimeter of space, and its effect is to push everything apart. While gravity pulls galaxies together, dark energy pulls them apart. And dark energy is winning. Think of it like this. Imagine space-time as a piece of rubber. Matter creates dips in the rubber gravity wells that pull things toward them. But dark energy is constantly stretching the rubber from all directions, making those dips less relevant, pulling objects apart faster and faster. The rubber is expanding. The dips are getting smaller relative to the expanding surface. Eventually, galaxies will be so far apart that they can't see each other. The universe will be dark and cold and lonely. We don't know what dark energy is. The leading theory is something called the cosmological constant, a property of space-time itself that causes it to expand. But it's really a placeholder. We're saying there's a constant value of energy in every point of space, but we don't know why that constant exists or what generates it. Now here's where this gets relevant to our main story. The Great Attractor and the Shappley supercluster are pulling us toward them due to gravity. But the expansion caused by dark energy is pulling us away from other galaxies. These are not opposing forces on the same scale. Dark energy operates uniformly across all space. The Great Attractor is a local structure. On cosmic scales, dark energy will eventually dominate. Billions of years from now, the gravitational influence of the Great Attractor will become cosmically insignificant. We'll keep moving toward it, but we'll also be accelerating away from everything else. This means the universe has an ultimate fate: cold, lonely emptiness. All matter will eventually decay or dissipate. All stars will die. All black holes will evaporate. The universe will expand forever, getting colder and emptier, until it reaches heat death maximum entropy, when everything is uniformly dispersed and nothing can change anymore. That's the future. That's where dark energy is taking us. You exist in a brief moment, a cosmic blink, where the universe is still interesting. Stars still shine. Galaxies still cluster together. Life can exist, but this window is finite. In billions of years, the future universe will be unrecognizable, uninhabitable, dark. And we're heading toward that future at an accelerating pace. Dark energy is the engine of that future, and we can't stop it. But here's the profound thing. We're alive now. We're conscious now. We can look back at the universe's history and forward to its future. We can contemplate these cosmic forces, and we can find meaning in our existence, despite or perhaps because of the universe's ultimate fate. We are rare, precious, temporary, and that makes us special. But before we get to the philosophical implications, there's something we haven't explored: the possibility that we might be wrong about all of this. Scientists have proposed alternatives to the Great Attractor model, hypotheses that suggest we might be misinterpreting the data. In the next section, we're examining the alternative theories and why some scientists think everything we've learned might be incomplete. Science isn't absolute truth. It's the best explanation we have given current data. And our current data about the Great Attractor is incomplete. We can't directly observe it. We can only infer its existence through the motion of galaxies. And sometimes, when we only have indirect evidence, we can be wrong. Some scientists have proposed alternative explanations for why the universe is flowing in the direction it is. One of the most interesting alternatives is called the Great Void or Local Void hypothesis. This theory suggests that the reason we're being pulled in a particular direction isn't because something is attracting us. It's because there's an enormous empty region of space behind us, and we're being pushed away from it by the density gradient. The void is pulling matter away from it. We're running away from the void as much as we're being pulled toward the attractor. Think of it like a bathtub with a drain in the corner. If one corner of the tub suddenly becomes very deep, a giant void, then the water doesn't necessarily get pulled toward that drain by suction. Instead, the pressure differential causes water to flow away from the shallow area toward the deep area. That's what the local void hypothesis suggests. We're not being pulled toward something. We're flowing away from the empty space behind us. The evidence for the local void comes from galaxy surveys. In one direction from us toward the region of the boats, void or the iridinous void, there are far fewer galaxies, and in other directions, the density of matter is significantly lower. This creates an asymmetry that could explain our cosmic motion without requiring a specific attractor pulling us. The push-away effect of the void might be sufficient to explain the observed bulk flow. Another alternative theory, proposed by some researchers, involves the possibility that we're not in a stable universe. We might be inside a cosmic bubble, an expanding region of low-density space that was created during the Big Bang's inflationary period. If that's true, then the boundaries of our bubble, where lower density space meets higher density space, would create flows. We'd be spiraling along the interior surface of our bubble. We might not be flowing toward anything. We might be part of a structure's internal circulation. What if the universe isn't infinite? What if it's finite but unbounded like the surface of a sphere? You could travel in any direction forever and never leave the universe. But there would still be edges where our local structure ends and another structure begins. If we're inside such a structure, The Great Attractor might just be the gravitational minimum of our local region, the deepest well in our bubble. These alternative theories aren't fringe science. They're published in peer-reviewed journals and debated by serious cosmologists. The problem is, our observations are ambiguous. Multiple theoretical models can explain the data. We need better data. We need more precise measurements. And that's where next-generation telescopes come in. The James Webb Space Telescope, the Future Large Synoptic Survey Telescope, and other observatories under construction will give us data precise enough to distinguish between these models. Here's something important to understand. Science advances through uncertainty. We don't have all the answers. The Great Attractor might be real. The local void might be the primary cause of our motion. Or some combination of both could be true. Cosmologists are still gathering evidence. The next decade of observations could fundamentally change our understanding of cosmic structure. But regardless of which model turns out to be correct, the fundamental truth remains. We're moving through space in a coordinated way. We're part of a structure. We're embedded in the universe's architecture. Whether that architecture pulls us toward a massive structure or pushes us away from a void doesn't change the basic fact. Our motion is determined by the distribution of matter and energy in the universe. And here's what matters most. Whether you're being pulled or pushed, whether the attractor is a real concentration of matter or a mirage created by local voids, whether the universe is infinite or finite, none of that changes the fact that you exist, that you're conscious, that you can contemplate these mysteries. That's what's truly significant. But now we've covered the physics. We've covered the astronomy. We've covered the mysteries and the alternatives. It's time to ask the questions that really matter. What does this mean for you? How should this knowledge change the way you see yourself? In the next section, we're shifting from the cosmic to the personal. We're exploring how understanding Earth's motion toward the Great Attractor should reshape your worldview. I want you to imagine something. Right now, in this moment, you are being carried through space at 600 kilometers per second. You are moving through the void of space faster than any vehicle humanity has ever built. You are accelerating towards something invisible that we still don't fully understand. And you're not moving alone. Billions of humans, billions of animals, trillions of plants, octillions of microorganisms, all moving with you, all being carried by the same cosmic current. Most people go through their entire lives without knowing this. They wake up, they have breakfast, they go to work, they interact with other people. They come home, and they never once think about the fact that they're moving through space at incomprehensible speeds toward something cosmic. They never contemplate their position in the universe. They never ask, why does this matter? How should this knowledge change the way I think about my existence? But here's what I want you to understand. The fact that you can know this matters. The fact that you can be told about the Great Attractor and understand it and contemplate it means something profound about what you are. You are not just matter. You are not just biology. You are the universe's way of becoming conscious. You are an expression of the cosmos's ability to study itself. Think of it like this. The universe created the conditions for chemistry. Chemistry created the conditions for biology. Biology created the conditions for consciousness. And consciousness, your consciousness, my consciousness, allows the universe to know itself, to study itself, to ask questions about itself. You are the mechanism by which the universe has become self-aware. You are not a passenger in a cosmic vehicle. You are an instrument of cosmic self-knowledge. When people first learn about their position in the cosmos, many feel insignificant. They think, I'm so small. My life is so short. My actions are so inconsequential compared to the vastness of space. And on one level, they're right. Your individual body occupies an infinitesimal fraction of space. Your lifespan is a cosmic blink. But that's not where the significance lies. The significance lies in what you can do. You can learn. You can create. You can love. You can contemplate the structure of reality. You can wonder about the universe and your place in it. You can pass knowledge to others. You can inspire future generations to ask better questions and seek deeper understanding. That's not insignificant. That's extraordinary. That's the whole point of consciousness emerging in the universe. When you understand that you're being carried toward the Great Attractor, something shifts in your perspective. Suddenly, the trivial problems that dominate your attention, social media arguments, workplace stress, relationship drama, they come into focus. They matter, but they matter in the context of something much larger. You are part of a cosmic story. The question is, what role do you want to play in that story? Some people find this knowledge disturbing. The idea that the universe has a preferred direction, that we're being pulled toward an unknown destination, that everything is ultimately headed toward cold, dark emptiness, they can trigger existential dread. And that's natural. But here's the perspective I want to offer. Being aware of cosmic forces doesn't diminish your life. It enhances it. It gives your existence context. It reminds you that you're part of something vast and ancient and ongoing. And here's something beautiful. You're not moving toward the Great Attractor alone. Everyone on Earth is moving with you. Every human who's ever lived, every human alive right now, every human who will ever exist, we're all on the same journey. We're all passengers on this planet being carried through the cosmos together. That's a profound connection. That's a reason for kinship. That's why human solidarity matters. We're all in this cosmic flow together. The differences that divide us, national borders, ethnic groups, religions, political ideologies, they're all temporary. They're all human creations that matter in the context of human society, but are cosmically irrelevant. What matters is that we're all conscious beings on the same planet, being carried toward the same cosmic destiny. We're all part of the universe knowing itself. We're all equally significant and equally small. But understanding cosmic perspective is one thing. Letting it change how you live is another. In the next section, we're exploring specific ways that cosmic awareness can reshape how you approach your life, your relationships, and your purpose. Most people encounter information about the Great Attractor or cosmic perspective and think, that's interesting. They feel a brief moment of awe, and then they go back to their lives unchanged. Their beliefs don't shift. Their priorities don't change. Their daily actions remain the same. I want to challenge you to let this knowledge actually transform you. The problem most people face is what philosophers call cosmic insignificance syndrome. You realize you're infinitely small in an infinitely large universe. You realize your impact on the cosmos is zero. And so you ask, why does anything I do matter? If the universe doesn't care about my actions, if I'm a speck of dust on a planet moving toward an invisible attractor, what's the point of anything? And that's a dangerous place for your mind to go. But here's a different way to think about it. The universe created the conditions for your existence. The Big Bang happened. Chemistry emerged. Stars formed. Planets formed. Life emerged. Consciousness emerged. All of this led to you. To this exact moment when you're watching this video, contemplating these ideas. That's not insignificant. That's the purpose. You're the universe experiencing itself. The cosmological arc bent toward creating you. Think of it like this. A raindrop falling into a river might think it's insignificant. It's tiny compared to the river. It doesn't change the river's course. But the raindrop is still part of the river. It still participates in the river's journey to the sea. Its existence matters because it's part of something larger. You're a raindrop in the cosmic river. Your existence matters because you're part of the universe's conscious self-awareness. Here's what will change your perspective. Everything you do, no matter how small, sends ripples through the universe. Not gravitationally, you're not that massive, but informationally, conceptually, you learn something. You pass that knowledge to someone else. They pass it to someone else. Ideas propagate. Understanding spreads. The universe becomes more aware of itself through your actions, through your thoughts, through your choices to share knowledge with others. That's how you matter cosmically. So how should this actually change how you live? First, pursue understanding. Learn about the cosmos. Learn about science. Learn about the structure of reality. Because every bit of knowledge you gain is the universe expanding its own self-awareness. Second, share that knowledge. Every person you teach about the Great Attractor, about cosmic flows, about the structure of space, that person becomes a node in a network of cosmic consciousness. Third, treat others with profound respect. Every human is equally part of this journey. Every person is an expression of the universe's self-awareness. That's grounds for radical empathy. Fourth, let cosmic perspective reshape your priorities. You're probably worried about things that, on a cosmic scale, don't matter. Career advancement, social status, material accumulation. These things are fine in moderation, but they shouldn't dominate your existence. What should dominate your existence is the pursuit of understanding, the cultivation of relationships, the creation of beauty, the reduction of suffering. These are the things that express the universe's highest functions through your consciousness. Fifth, cultivate gratitude. You exist. Against impossible odds. Given the vastness of space and time, given the random nature of cosmic events that led to your existence, the probability of you being here is almost impossibly small. Yet here you are, conscious, aware, able to contemplate the cosmos. That's grounds for profound gratitude. Not necessarily religious gratitude. You don't need to believe in God to be grateful that you exist. Just cosmic gratitude. Appreciation for the improbable miracle of your consciousness. When you really let this sink in, that you're traveling through space at speeds beyond comprehension, toward something unknown, as part of a cosmic journey that's billions of years old and might continue for billions of years into the future something happens. You feel smaller, yes, but you also feel connected. Connected to every human who's ever lived. Connected to the stars that created your atoms. Connected to the universe that created you. That connection is what matters. And when you inevitably feel moments of despair, when you think about the ultimate fate of the universe, about entropy and heat death and cosmic cold and loneliness, remember this. That end is billions of years away. You're here now. You're alive now. The universe is still bright. Stars still shine. Beauty still exists. Make the most of this cosmic moment that you're privileged to experience. But perspective is just the beginning. In the next section, we're going to explore something even more concrete. How understanding the Great Attractor reveals something fundamental about the nature of reality itself. We're going to talk about what the Great Attractor tells us about whether we're living in a special place in the universe, or if we're typical. There's a principle in cosmology called the Copernican principle. It says that Earth occupies no special or central position in the universe. We're not at the center of creation. We're not privileged observers. We're typical, average, mediocre. And that principle has been one of the most important ideas in the history of science because it's been right, again and again. When we've tested it, Copernicus said we're not at the center of the universe. We orbit the sun. He was right. The sun is one star among billions. Herschel said the sun is in the outskirts of the galaxy. He was right. We're on a galactic arm in the suburbs of the Milky Way. Modern cosmology says we're in an unremarkable supercluster, in an unremarkable region of the universe. Probably right. The Copernican principle suggests that wherever we are, it's typical, not special. But the Great Attractor raises an interesting question. What if we're not just typical? What if we're in a special region, not because we're the center, but because we're near a massive attractor? What if the Great Attractor's gravity has shaped the structure of our local universe in a way that's uncommon? What if our position, while not cosmically central, is somewhat unusual? Would that violate the Copernican principle? Think of it like this. If I tell you that all towns are typical, and therefore your town must be typical, you might agree. But if you then find out that your town happens to be next to a large river, And river towns have different properties than non-river towns. Does that violate the principle that your town is typical? No, it just means you're typical among river towns. You're in a typical position relative to the attractor, but you're near an attractor. So here's the real question. Is being near a major gravitational structure common or uncommon in the universe? The honest answer is, we don't know. We can't see the entire universe. We can only see the observable universe, about 46 billion light-years in all directions. And within that observable universe, the Great Attractor is one of several major structures. It's not unique. It's not the only attractor. There are other structures pulling in other directions. But here's what will blow your mind. There's an asymmetry in the observable universe that suggests we might not be typical. On one side of the sky, there's the Shappley supercluster pulling us toward it. On the other side, there's an underdensity fewer galaxies, less matter. That asymmetry tells us that we're in a region of space that has structure. Structure implies we're not uniformly distributed. Structure implies that being near a massive attractor might not be as common as being far from one. This raises an interesting philosophical question. If massive attractors create conditions favorable for galaxy formation, and galaxy formation creates conditions favorable for star formation, and star formation creates conditions favorable for life, then is it possible that observers like us are more likely to exist near attractors than away from them? Could we be observing a special region simply because observers can only exist in special regions? This is called the observer selection effect. This idea has been explored by cosmologists like Brandon Carter, who proposed the anthropic principle. Carter argued that our observations are necessarily biased by our existence. We can only observe the universe from a place where observers can exist. If observers require certain conditions, like stable galaxies, stable stars, stable planets, then we'll necessarily find ourselves in those conditions. We won't necessarily be typical. We'll necessarily be in a region capable of supporting observers. This doesn't mean the universe is designed for us. It means we're evolutionarily and physically constrained to exist in certain environments. Just as fish don't find it surprising that they live in water, because fish that live on land don't survive humans. Don't find it surprising that we live in a region capable of supporting humans. But if you expand that to cosmic scales, you realize that intelligent observers will naturally find themselves in unusual regions of space. We're unusual not because the universe is designed for us, but because we can only observe the universe from places where observers can emerge. This is one of the deepest insights in cosmology. Our position in the universe appears special because we're asking the question from a position where it's possible to ask the question. We're near the Great Attractor, in a galaxy, orbiting a star, on a planet capable of life. But is that special? Or is that just the only place from which the question can be asked? This paradox, the paradox of observer position, is something cosmologists are still grappling with. And here's what it means for you personally. Your existence isn't an accident, but it's not designed either. You exist because the universe created the conditions for your existence. You exist because matter concentrated in just the right way to form stars and planets. You exist because your ancestors survived and reproduced. You exist because atoms forged in stellar furnaces happened to combine into the molecules that became you. That's not design, that's emergence. And emergence is perhaps more profound than design. We're getting close to the end of this journey, but we're not there yet. We've explored the cosmic facts. We've explored the personal implications. Now it's time to explore the big question. What comes next? What does the discovery of the Great Attractor and cosmic flows mean for the future of humanity and our understanding of reality? In the next section, we're exploring the future of cosmology and what we still don't know. We've covered a lot in this video: the Great Attractor, cosmic flows, dark matter, dark energy, the structure of the universe. But here's something important you need to understand. We're still at the beginning. For every answer we've found, there are 10 new questions. For every mystery we've partially solved, we've discovered bigger mysteries. The future of cosmology is going to reveal things that will make the Great Attractor look simple. In the next decade, several things are going to happen that will revolutionize how we understand the cosmos. First, the James Webb Space Telescope and its successors will observe galaxies so distant that we're seeing them as they were in the ancient universe. We'll see how cosmic structure formed. We'll see how the Great Attractor and other structures grew over billions of years. Second, new surveys of hundreds of millions of galaxies will map the cosmic web with unprecedented precision. We'll know the distribution of matter in space better than ever before. Third, gravitational wave detectors are becoming more sensitive. We'll detect mergers of massive objects and learn about the invisible universe of compact objects. Think of it like this. Right now, we're looking at the universe like someone standing inside a forest looking at individual trees. We can see nearby trees clearly, but the forest extends far beyond what we can perceive. In the next decade, we're getting better binoculars. Then we're climbing a hill to see farther. Then we're getting an aerial view. Each time, we understand the structure of the forest better. The Great Attractor is like a distant hill in the forest that we've only recently discovered exists. There are many more hills and valleys we haven't found yet. Here are the questions that keep cosmologists awake at night. First, what is dark matter actually made of? We've been searching for decades without a definitive answer. Second, what is dark energy? Is it the cosmological constant? Is it something else entirely? Is it changing over time? Third, is the universe infinite or finite? If it's finite, what's its shape? Can you travel in one direction forever and come back to where you started? Fourth, does the universe have a center? Or is the Big Bang the only special point in space-time? Fifth, are there other universes? Is our Big Bang one among many? Would other universes have different physical laws? Sixth, could the Great Attractor be something stranger than just a concentration of matter? Could it be a topological feature of space? Could it be a remnant of the universe's earliest moments? Seventh, are we measuring cosmic flows correctly? Could our measurements be misleading us? Could there be selection effects we're not accounting for? Here's what will blow your mind. Some physicists think the universe might be conscious. Not in a mystical way, but in a fundamental way. They propose that consciousness might be a property of matter that emerges when matter reaches sufficient complexity. If that's true, then the universe's drive toward creating conscious observers like us might not be accidental. The universe might be organizing itself to become aware of itself. The Great Attractor might not just be a gravity well. It might be part of a cosmic drive toward complexity and consciousness. Now, that last point ventures into speculation. It's not currently testable science. But that's what's exciting about cosmology. We are at the frontier. We're asking the biggest questions we can ask. And some of our answers might seem like science fiction, but they're grounded in observations and mathematical models that are being tested constantly. Groups like the Sloan Digital Sky Survey, the Dark Energy Survey, the 2DF Galaxy Redshift Survey, and upcoming surveys like the Large Synoptic Survey Telescope are constantly refining our understanding of cosmic structure. Gravitational wave detectors like LIGO and Virgo are revealing the invisible universe of merging black holes and neutron stars. Space telescopes like the James Webb are seeing deeper into the ancient universe than ever before. These aren't isolated efforts. They're coordinated, collaborative projects involving thousands of scientists worldwide, all working to answer the deepest questions about the cosmos. And here's something cool. You can participate in this. Citizen science projects allow anyone to help classify galaxies, identify exoplanets, or analyze cosmic data. By engaging with these projects, you're literally helping to map the universe. You're part of the human collective effort to understand our cosmic place. That's not metaphorical. That's actual scientific contribution. The Great Attractor is just one piece of a much larger puzzle. As we gather more data, map more cosmic structure, and develop better theories, our understanding will evolve. The Great Attractor might turn out to be just the nearest major attractor in a universe filled with similar structures. We might discover that the universe is far more structured and organized than we currently believe. We might discover that cosmic flows are fundamental to how the universe works. And all of this leads to the final question we need to explore. If everything we've learned is true, if we're indeed moving through space toward the Great Attractor, if cosmic flows are shaping the distribution of matter, if we're ultimately headed toward cosmic death and entropy, what does that mean for meaning? What does it mean for purpose? How should we live knowing all of this? In the final section, we're bringing everything together. We've been on a journey. We started with the revelation that you're moving at incomprehensible speeds through space toward something invisible. We've explored the science of cosmic structure. We've examined the personal implications. We've discussed future discoveries. Now, I want to bring this all together and offer you a perspective that might reshape how you understand not just the cosmos, but yourself. Here's the fundamental truth we've established. You exist in a universe that is dynamic, structured, and mysterious. You're moving. Everything is moving. Motion is fundamental. Your atoms came from the cores of dead stars. Your consciousness emerged from the organization of those atoms. Your existence is dependent on physical laws that seem fine-tuned for the emergence of complexity. And you have the capacity to understand, at least partially, the universe that created you. Think of it like this. The universe is a symphony that's been playing for 13.8 billion years. Physical laws are the musical notes. Particles are the musicians. Stars are the instruments. Galaxies are the orchestras. And consciousness, your consciousness is the universe, finally hearing itself play. You're not an accident in the symphony. You're the part where the symphony becomes aware of itself. Now, many people, when confronted with the cosmic perspective we've discussed, feel a paradox. If I'm small, if my life is brief, if the universe is ultimately headed toward entropy and cold death, how can anything mean anything? How can I find purpose? And that's a legitimate question. That's the question I want to address in these final minutes. Here's what I want to propose. Meaning isn't something that has to be given to you by the universe. Meaning isn't something that has to exist independently. Meaning is something you create. The universe created consciousness you, and consciousness creates meaning. Your life is meaningful because you decide it's meaningful. Your relationships are meaningful because you value them. Your actions are meaningful because they have consequences in the world. You don't need the universe to validate your meaning. You are the part of the universe that generates meaning. Here's what will blow your mind. The Great Attractor might not be pulling us toward anything. It might be pulling us toward ourselves. Think about it. We're conscious beings emerging from the structure of the universe. We're the universe becoming aware of itself. As we learn about the Great Attractor, as we contemplate cosmic flows, as we map the structure of reality, we're the universe studying itself. The Great Attractor might be the gravitational center of a region of space that naturally gives rise to complexity in consciousness. We might be at an attractor because attractors are where matter becomes organized enough to become conscious. The Great Attractor might be calling us toward our own nature. You asked at the beginning where you were listening from. I asked you to comment. And I want to know, because you're now part of a conversation. Thousands or millions of people are watching this video, contemplating these ideas, thinking about their place in the cosmos. You're not alone in this. You're part of a species that's becoming conscious of the universe. That's happening right now. And you're participating in it just by thinking about these ideas, just by letting them change you. When you understand that you're moving toward the Great Attractor, when you understand that you're made of stardust, when you understand that you're a temporary expression of consciousness emerging in the universe, something profound happens. You realize that you're not separate from the cosmos. You are the cosmos. You are the universe in a temporary, localized, self-aware configuration. Your consciousness is part of the universe's consciousness. Your knowledge is part of the universe's knowledge. Your love is part of the universe's love. This changes everything. It changes how you treat other people, because they're the universe experiencing itself through a different body. It changes your relationship with nature, because nature isn't something outside you. It's an expression of the same cosmic principles that organize you. It changes your attitude toward knowledge and learning, because every bit of understanding you develop is the universe understanding itself through you. It changes your sense of purpose, because your purpose isn't something external. It's the universe's purpose of experiencing and understanding itself, expressed through your existence. The Great Attractor isn't just a cosmic mystery. It's a mirror. It's showing you something about yourself. It's showing you that you're part of something vast, that you're connected to everything, that your existence matters because the universe matters, that the universe matters because you're conscious enough to know it matters. You're the part of the cosmos where the cosmos becomes real to itself. When you feel small under the stars, remember, you're made of the same atoms as those stars. When you feel insignificant in the face of cosmic forces, remember, those forces created you. You're not outside them, you're an expression of them. When you feel overwhelmed by the vastness of space and time, remember, you're experiencing that vastness from a unique perspective that no other part of the universe experiences. Your particular way of being conscious, your particular combination of thoughts and feelings and ideas, that's unique. That's precious. That's cosmic. You asked what Earth is moving toward. The answer is, you're moving toward the Great Attractor. But the Great Attractor is also everywhere. It's in every gravitational interaction, every emergence of structure, every appearance of complexity. It's in you. Your body is organized by the same gravitational and electromagnetic forces that organize galaxies. Your mind is structured by the same laws that structure the cosmos. The Great Attractor and the Great Attracted are ultimately the same thing, the universe organizing itself into more and more complex configurations, each one more conscious than the last. And you're part of that process. You are that process, seeing itself. So here's what I want you to do. Go outside tonight and look at the stars if you can. Think about the distances. Think about the light reaching your eyes. Think about the fact that you're looking back into time. Those stars you see, some of them are dead. The light traveled for years to reach you. You're always looking at the past. You're always contemplating the ancient universe. And as you contemplate, remember, the universe is contemplating itself through your consciousness. Make that contemplation meaningful. Pursue understanding. Share knowledge. Create beauty. Reduce suffering. Love consciously. These aren't just nice things to do. They're expressions of the universe's deepest nature. To know itself, to care about itself, to evolve into more complex forms of existence. Thank you for coming on this journey with me. If this perspective has changed how you see the cosmos or yourself, I want to hear about it. Comment below. Tell me where you are. Tell me what you're thinking. Tell me how cosmic perspective is reshaping your worldview. And if you want more of these deep dives into the nature of reality, hit that subscribe button. Enable notifications. Let's continue this conversation about the universe and our place in it. Because the more of us who understand these cosmic truths, the more conscious the universe becomes. And that matters. That's everything. Thank you.